I think the first thing I want to mention this in this episode is I booked my ticket to the server-side Swift conference. Did you book a ticket?
I did in fact book it. I booked the ticket, booked the hotel. The only thing I haven't booked yet is the flight. So looks like we'll finally meet. Fingers crossed.
You're well ahead of me then, because I haven't yet booked the hotel, but I do have a ticket. And yes, it will be nice to both be in the same place at the same time, because you went last year, and unfortunately I was not so well last year when the conference was on, and so I couldn't attend. And then the year before I was there, but you couldn't attend the year before. So we've nearly met at the conference twice now. But this year, this is the one.
It's the one, exactly. Only took us 5 years.
It only took us 5 years, exactly. But just for anyone who is interested, it's worth mentioning the details of the conference. Early bird tickets are still available, and if you have any interest in server-side Swift, which if you're listening to this podcast, you probably do, then the Server-Side Swift conference is 2nd to the 3rd of October 2025 in London, and like I say, early bird tickets are still available. There's no speakers or schedule up yet. In fact, I think there's still an active CFP for the conference, so maybe you could even speak at the conference if you're listening to this. Yes, the CFP still appears to be open until June the 30th. There we go. So you may, if you have something interesting to talk about at the conference, submit yourself a CFP, but if not, then consider a ticket if you've interest in server-side Swift.
Yeah, and if you're, as Dave said, if you're interested in server-side Swift development at all, just get a ticket. You don't need to wait for the speaker list, because the speakers will be great.
Yeah,
it was a great conference last year, and the talks are, they're certainly very important, but also everything around the conference is really great. There's a lot of time to catch up, socialize, meet people. I found it really great. Lots of people I'd only interacted with online that I had a chance to meet last year. And the few that I didn't manage to bump in, I hope to run into this year. And same for everyone else. I think it's a great venue too. We should mention this is happening at the Science Museum in London. Yeah. So even if you don't want to talk to anyone at all, you can just roam the halls and look at the lunar lander and stuff like that. Look at old airplanes and that stuff. But you should talk to people.
Yes, you should. That's the best bit of any conference. The year before last, I actually did a small presentation at that conference, and the venue is fantastic. Of course, the Science Museum is wonderful, but it's in the at the time when it was 2 years ago, it was in the IMAX theatre there, and so my slides were projected onto an IMAX screen, which is the first time I've ever had that happen. So that was fantastic.
Yeah, it's a great venue.
You don't really know what big fonts are until you've had them projected on an IMAX screen. So that's that. I think there's also a couple of little bits of news from the project over the last couple of weeks. First of all, we shipped 2 new compatibility platforms for our compatibility matrix on every package page. So there was a blog post, and we'll link the blog post in the show notes, but we have added both Wasm and Android to all of our compatibility checks. And it's been kind of interesting to see the results of those platforms. They are significantly more compatible already than you might expect. Now, obviously, whenever you have a package that relies on any of the kind of Apple-specific platform UI kit, Swift UI, App Kit, any of those kind of things, you're automatically going to fail compatibility with both Linux and Wasm and Android. But actually, I was pleasantly surprised to see that almost 19% of packages are already compatible with Wasm, and almost 28% are compatible with Android already, which is kind of remarkable.
Yeah, it's great to have those platforms in. It was really surprisingly easy to actually add them thanks to the Swift cross compile efforts. So I think this was introduced with 6.0, like the SDK support. And now with Swift 6.1, Android came on board as well. And it's really like you install these SDKs alongside your toolchain, and that allows you to compile to the target platform. So I think what effectively it does is sort of the SDK is a bundle of artifacts you need to cross compile, like headers and additional libraries and stuff, and then you can run on your host platform and compile to the target platform. And because we've already been running Linux builds, it really meant just creating almost like a variant of the Linux build in both cases, because the builders are Linux based in those cases, and you install the additional SDKs and you just compile to Wasm and Android. And it took some testing and stuff, but it was easy to add. And like every year, I just hope that at some point we'll even get to something similarly easy with the Apple platforms, because we still have to wrestle whole Mac virtual machines for all of those platforms. If those SDKs also had something like that, that would be amazing, and make it much easier to run these compatibility builds across the board.
The big one, of course, that's still missing is Windows, and that is something that we would both love to have on that compatibility matrix, which would take our number of platforms from 8 to 9. But we do still have a couple of kind of technical issues. The software that we've built to run the builds that we use for compatibility testing has a couple of dependencies that are not yet compatible with Windows, and so that would be quite a lot of work to work around those dependencies. But also, we would need to flesh out an entire kind of Windows build infrastructure, which is something we don't have, and unfortunately, we're on the verge of losing our Microsoft Azure sponsorship. So it's also not something that we're able to kind of put a whole load more resources behind in terms of that build infrastructure right now. So it's definitely on our minds. We'd love to do it, but it's not in our short-term future, I don't think.
Yeah, unfortunately not. It's interesting how often it actually comes up. Like Windows support is being requested quite frequently.
Yeah.
The main dependency we're lacking is Swift Neo, and I do know that there's interest in actually porting that. I know the Vapor folks are sort of interested in that as well. They have lots of requests, surprisingly, for Vapor on Windows, and that's obviously a dependency for them as well. So I'm confident that'll see changes at some point. It can't be too far off. There's a lot of interest in Windows, and I think we'll get it sooner rather than later. Fingers crossed.
Yeah, absolutely. And then, so we've actually published 2 blog posts in the last 2 weeks, which the second one was a little celebration of our 5-year anniversary of the launch of the Swift Package Index. So we launched just before WWDC 2020, which, if you remember, was actually a little delayed in 2020 because I think there was some global event happening or something like that, but I forget now. So WWDC was a little delayed, but we launched just before the conference in 2020, and we published a little blog post with some statistics and some kind quotes that people gave us about the package index, with a couple of graphs showing how package growth has happened over the last 5 years, and how much documentation we host and how many builds we do, and all sorts of stuff. So again, I'll include a link in the blog in the show notes to that blog post.
Yeah, and on that occasion, thank you to everyone who's supporting and using the project. It's just amazing to see how much it's grown. Like we started with, was it 2,500 packages? It's 9,000 now. I mean, of course, it's not a lot if you compare it to other ecosystems, but it's a lot of growth in those 5 years. has a lot of really interesting and fun packages, and helps. Like I use it a lot, actually, the site itself, to find stuff, and not just because of the Swift package index, but just of work in other aspects of the project itself, but also sometimes when I try stuff. It's a site I use often, and interestingly for me, use has shifted to looking up the documentation pages much more. Like, I think if I had to say what I use the site for, has dramatically shifted towards documentation, and I think that's really a testament to the efforts by the community to actually add documentation to their packages. I'm constantly amazed how high the ratio is of new packages that are being added with documentation opt-in, and the quality of the documentation in particular. There's lots of packages that have good documentation, and some have like amazing documentation with tutorials and migration guides. It's fantastic work being done there. So thank you, everyone.
Yeah, absolutely. Thank you so much for not only using it, but the people who also sponsor us through GitHub. That's incredibly important to this project being as successful and available as it is. So it's been a fantastic 5 years of running it. So thank you very much.
Here's to the next 5, and then some.
Exactly. Yeah. Exactly. Yeah.
All right. I think there's another big thing happening this week. You just mentioned it, like 5 years ago.
Is there?
It's like 5 years ago. We launched just before WWDC. The actual 5-year anniversary is probably exactly on the day this podcast episode will come out, which is in the middle of WWDC 2025. And we've had an interesting keynote yesterday and State of the Union, I think. Did you sacrifice any of your devices yet on the beta altar, or did you?
No, not yet. So we should mention that we're recording this on the Tuesday, so that's as of today, we've only seen the keynote and the State of the Union. Although I did notice that it appears that every session video has been released yesterday.
It's all there. Yeah.
So I have a feeling that unlike previous years where they do a few every day throughout the week, I think they've just dropped the entire set this year, which is great. But the only ones I've watched so far are the keynote and the State of the Union. And I haven't yet sacrificed any of my devices. The only thing I've done so far is install Xcode 26.
Yeah.
Which is well, actually, there's something I before we move on to what we thought of the thing. I read a blog post today by Daniel Seide, who made the case as to why the unified OS versioning is a huge advantage to us as developers. And it's basically around all the availability checks for things like SwiftUI, where you might say before you declare a function or before you use a function, you might say when available on iOS 18, macOS 15, tvOS 18, watchOS 11, and visionOS 2, you now will presumably just be able to say, you now say, please check for OS 26. And that covers everything now, which I think that's one practical advantage for developers of the naming system changing. It will take us a little time to get used to that naming system change, but I think it's a good thing, because generally you do want to, when you're doing those availability checks, you do want to set everything with every platform at a certain year. So I quite liked that, and I'll include a link to that blog post in the show notes again.
Yeah, no, I think that makes perfect sense. The change to years. The 2026 is a bit, like it's not 2026 yet. And I can see how they want to, not when it probably hits the mainstream, it's going to be 2026. But then I'd argue you should have probably also called it WWDC 2026, right? No, I think this makes sense to me. WWDC is very firmly in 2025, but the operating systems 26 don't actually release until September and October this year, at which point
we are much closer to 2026 than we are to 2025. And so I think it does make sense that the majority of the time that iOS 26 will be available, not in beta, will be in the year 2026.
Yeah, I mean, this is a lot like, $9.99 pricing. It's like it's targeting the psychology more than anything else. Decision, though.
Yeah. I would have made the same decision. Given if it were a June release date, I would probably go with 2025. But given that we get access to it way in advance of the people who are actually going to eventually use it, I think it's the right decision. Given it's September and October when they normally ship.
All right.
I thought the conference was good. Yeah, the State of the Union was interesting. I didn't quite make it to the State of the Union last night, but I watched it today. Interesting changes to lots of the frameworks. I got the new changes to Xcode, which are good. One that I didn't expect was the Swift Assist feature to be in this year's version. I thought that might be a little further delayed, and also for it not to rely only on the Apple model for prediction, and actually it's more than prediction. It is it's not quite it's not an agent, but it is a chat that you can have with an LLM about your code that will also write code for you, but you can go backwards and forwards in that chat. It's definitely more than code completion.
Yeah. And I didn't actually see that called out. Is that the Swift Assist equivalent? But because I don't think they mentioned Swift Assist.
I think the words Swift Assist were very deliberately not mentioned yesterday. Right. Yeah. At least I didn't hear those two words said at all. But from what was previewed as Swift Assist the year before, this feels like an evolution of what that was.
Yeah, definitely. It's great to see that they have the on-device models and stuff, and that you can very easily interface with them. I played around with it a bit. Foundation models. It's super easy to use. I mean, I'd be interested
that's the
to
one
see
in the SDKs, right?
Yeah, I'd be interested to see the quality of it and what it can actually do. I just did a trivial thing, and it's hard to judge them from just a couple of things. You really need to gain experience with those to be able to judge them. But you can see how in the future with more advancements, this is a really interesting and compelling thing to have, that you don't need to reach out, you don't need to fiddle with API keys, that it runs on device without a network connection, without shipping your data off. That's just massive benefits. And if it has quality that's sort of in the ballpark, I think that gives it a lot of weight. Even if it's not maybe the most cutting edge model, I think there's a case to be made that it's a trade-off you might want to make in those cases. Plus, you can still do the other thing if you really feel like you need the extra,
of course,
the extra oomph if it exists. Yeah.
I'm much more excited about the coding support than the foundation models, just simply because that's something I've been kind of interested in for a little while in Swift coding and in non-Swift coding actually. And I did a little experiment at the beginning of, and it was the end of last week, I think, that I did this, where are you familiar with Claude Code?
Yes.
Okay, so Claude Code, if you're not familiar with it, is what they call an agent for writing code with one of these LLMs, in this case Claude. And I was curious to try something with it. And so I actually got it to write me a Swift package this week, and that Swift package, I think, it is in the Swift package index as we speak. And what I did was I spent about an hour writing and refining, with the help of some LLMs to help me do that, writing and refining a a quite detailed specification for the package, and then using a technique that I learned from Peter Steinberger, who has been doing a lot of work with these agents at the moment. I found it very interesting to basically pass this specification between two LLMs, so that I took it from the one LLM and read it and made sure that it was correct, and corrected a few things or added a few things that I wanted this package to do, and then I passed it to another LLM and said, please find me the weaknesses in this specification and ask questions about those weaknesses, and I took the response of that and also then added some answers to those questions, and then passed it back to the first LLM and said, please integrate these changes into the spec. And ended up, after about an hour's worth of work with what was quite a detailed specification for a Swift package, to parse a markup language called Critic Markup, which is an extension to Markdown, where you can mark additions and insertions and substitutions in written text. So you can do like a little brace and then plus plus and then a word and then plus plus and then the closing brace, and it knows that you want to insert that word into the Markdown document. Think of it a little bit like track changes in pages, but in a Markdown format. And so I had it write this spec, and then I gave that spec to Claude Code. I just said, please implement this, including a full test suite, including DocC documentation, including Markdown files that include examples of DocC documentation, as well as just the documentation for the structures and classes themselves. And it went away and thought about it for probably 45 minutes, something like that, and spat out a package. And if you look at, so I was actually watching it do its work for most of the time, and you could see that it was not only building and running the test suite, it was then kind of refactoring the code it had written for better testability, and then writing a test then to test it, and then running the test, make sure they pass, writing documentation. And after 45 minutes, I had a package that was working, just kind of remarkable, that it needed literally no intervention from me at all. Now, I would want to test that package further. In fact, I hesitated before adding it to the index, because I haven't used that package in Anger, but I have used it in a little demo application. And of course, the tests are there, and the tests do what they say they will do because there's tests. So it was very interesting to do that. And so the reason I mentioned that is that what has shipped in Xcode 26 is a step towards that, but already, and this stuff is moving so fast at the moment that already what was released yesterday is a little bit behind state of the art, because that kind of stuff was a few months ago, and we are talking like literally just a few months ago. But it makes a real difference for the LLM to be able to interact with your tools in terms of, I think it's time to run the test now, so I'm going to run the tests and I'm going to look at the output from those tests and see if they pass. And then if they don't pass, I'm going to look at the error message that it gave me and then rewrite the code. And so it's a real huge step along that path, which, I thought it was I wanted to experiment with it. And I felt that was a decent experiment that I came up with.
Yeah, no, it's remarkable, the capabilities they've gained. I mean, we've touched on this a couple of times. We have slightly different points of view on the whole AI stuff, although I think a lot of it is also aligned. I think it's initially my main complaint was that it doesn't actually work, or didn't seem to work, but I had to revise that a bit. I tried independently. I tried actually something just before Peter Steinberger came out with his blog posts and the video about trying this. I had just tried the Z editor has integrated Claude thing, and I used it to write a script. Like when we ran the Android and Wasm compatibility. We did a comparison against the Skip Tools page where they had run a compatibility test themselves as well, and I wrote a little Swift script to compare their list of results versus our list of results. And you can imagine writing a script like that is not a big task, and it took me a little less than 20 minutes to do it, and compare the results and verify that it is okay. And even before I started, I thought maybe that's something I should try, compare how I do versus how Zed with Claude does. And obviously, if I was to do that, I had to do it myself first, because, what's the point watching the thing, and then it's then harder to do it yourself when you have a finished thing. But interestingly, once I'd finished writing the script, on the same day, I pulled up Zed, and then I was looking at the prospect of describing to the thing what I wanted to do after I'd just done it. And I couldn't even find the energy to start writing a prompt to tell it what I wanted to do, because I had it, I had just done it. So I said, no, I'm not going to do this. This is silly. But then the next day I was sort of fresh. I thought, all right, let's fresh new day. Let's go and do it again. And I honestly, I'll admit, I didn't think this would actually work at all. Because from everything I'd seen, these sort of wander off and do stuff, and like a Swift script. This wasn't even a package. This was a Swift script. I think I might have turned it. I think I turned it into a package. I don't remember. Anyway, it wasn't a trivial thing. I mean, it wasn't a super complex thing. Not anything like what you've done or what Peter has done. But still, I thought this would be too complicated for this to understand what I want, because there were a couple of things that were kind of tricky. Like the two input formats were JSON, but they were different. They weren't structurally the same. Not even, one was an array, the other was an object with leaf items and stuff like that. So it was more than a absolutely trivial task. And I didn't think it would manage, and it did manage, and it managed in a form that was acceptable. I had no complaints. I ran a couple of additional iterations, told it, look, we should refactor this a bit and this a bit. I was done after 10 minutes, so I was faster with the thing. I think the only thing where I benefited from having done it before myself was that I caught a couple of edge cases while I was doing it. And that's the problem I have with these tools. I wonder how much of an edge you lose thinking about your problem deeply when you're not actually doing it. Like I noticed when I ran the results after I manually compared them that the numbers seemed low, and I realized that the URLs that were compared were actually had different casing. And that's a rather trivial thing to realize and know, but also because we've had this situation in the past. So all of our comparisons with URLs are always lowercase and then compared for that reason. And so I had I spotted that, but I think I spotted that faster because I had actually just written the map and the comparison, and you are in the vicinity of the issue when you're in that mindset. I think if I just sit down and I want this compared, and then I look at, all right, you're more tempted to accept what you get. And I had the same effect with, it's sort of like the complaint dialogues. You start clicking on accept, like also when it wants to confirm, can I run this tool? Initially I had it always to confirm, and then at some point you give in because you have this. Your resistance gets worn down. Why do I always need to accept? Yes, you're just going to run Swift build again. Okay, so I click accept. And then at some point I said, well, just run it. Just goddamn it, just leave me alone and run it. And that's the thing that I fear most with the actual use of the tool, is that my vigilance and my just my awareness of what I'm actually doing is going to, it's like taking over a self-driving car. You're never going to be able to take over when actually it gets critical, right? Because you're not in the system. You have no state of the operation, like what state is the system in, then you're supposed to jump in and take over. And that's what I find so hard. And I feel like I really fear that losing capabilities and losing ownership and control over the system as a whole. And I do realize that we've had this before. Like every tool sort of removes you a bit from control. Like people used to hand roll assembly, right? I have no idea how that actually works.
Yep.
So I think... And that's why I was interested in actually doing it. I wanted to do that experiment because I felt like, I can't just sit there and complain that these things don't work if I've actually never tried it in earnest. So I wanted to understand, because I don't think people like Peter are making this up, right? And he's not the only one. There's others who've been using this. And I think there's a scale. Like there's people who just blindly, quote unquote, vibe code and just have no sense of what's going on, and there's people like Peter who are, he's an expert, right? And he's, if you give me a jackhammer, all I'm going to do is ruin whatever I'm doing, right? It's not the right tool for me. But there's people like Peter, you can hand a tool like that and he'll use it responsibly and get amazing results out of it. So I think there's this aspect as well.
It's definitely there's definitely a skill to using these tools. That's 100% correct. And I've been using it for the kind of script that you were writing to compare those results that you talked about. I've been using it for that kind of task for many months now. And I was 100% convinced that it was extremely good at writing that kind of code. This is the first time that I've ever told it to write something from start to finish. And I think your point about the edge cases and the things that you discovered while you were writing your own version before you asked the AI to write it, I definitely found that with this project through the specification phase. Like the very first version of the specification, when I read through it, it didn't make sense, because I hadn't thought, and I'll be specific, otherwise it's going to be very difficult to talk about. Critic markup has the ability to nest critic markup inside critic markup. And actually, when I told it to write the spec the first time, I didn't realize that was even a thing, but it figured out that was a thing in critic markup, and then it just started making up how that should work, right? And because I hadn't told it otherwise. But I didn't know that it was able to be nested, and so I hadn't thought about that at all. And so in the revision to the specification, I made some rules about what should happen with the nested markup. And actually what I said is that it shouldn't support nested markup, and it should just, anything inside a markup piece should just be treated as the output, so that if there was nested markup, then it would just verbatim echo that as the original text. But that thinking through of that specification process was really, really important. And I think that's why it took me longer to write the specification than it did to write the code.
Yeah, I mean, it's certainly a shift in skill set. I'm not sure if I'd be happier writing specs than writing code. That's the other thing. I mean, that's probably, that really depends on where you land in what parts of the system you like. Like I love writing tests, for instance, and I'm probably in the minority. So we all have different aspects of a system that we like, right? And I also find that's why I'm so a bit worried about offloading these parts to the LLM. Is I often write a test and then I think of adjacent tests as I'm writing that test. And I fear that if I don't write tests, I lose that branching out and discovering edge cases that way. It might still happen in other ways. I'm just worried about that. So one of my biggest complaints about this whole AI, and I resist to call it that still, the LLMs, is the aspect that I didn't trust them to work well enough. I think there's still areas where they're too blindly deployed and taken for truth when the results, especially when the results aren't verified and the operator isn't actually able to verify them, and still they accept the results. I think that's a huge problem. And then the other big problem is like the provenance, like where is this all this knowledge coming from? And we've discussed this in the past, like
Yes.
and we see the effects actually on the Swift package index. We're getting hammered by AI crawlers since end of last year, and they come in waves, and they're just slurping up all the data they can find, and it's not theirs, it's not their data. I actually had I talked to my partner over the weekend, and I came up with this description. It's like people are using steroids and everyone else is getting acne, right? Because they are using all the data out there and boosting their own systems. But everyone else is paying the price. Like if I actually insisted never to use an AI system, LLM system to help my work, I'd still be affected. And not just the down the line effects because people use LLMs to create fake news and whatnot. We see all these effects already, like society wide, but actually tangible effects where our system is getting hammered by AI crawlers, and our systems are running hotter. We probably have to pay more for plans that are traffic related at some point, if not already, because of that. So we are bearing a cost, and it's not the companies that are actually benefiting from the sales of these AI subscriptions eventually that are actually paying for it. And that's not even talking about the intellectual property that's getting copied, like the copyright violations that are happening, and I'm just wondering how that's going to play out. Yeah.
I think the IP issue is much more of a problem outside of code, actually, because for example, in art and writing and all of that stuff, because the majority, if not all, of the code that's being slurped up is open source. So that there is very little IP. Although I had a big issue with this when they first came out, which was they were clearly trained on all open source code regardless of open source license, and so that includes a whole load of GPL code. And at what point does that GPL code not get covered by the GPL anymore? It doesn't. They are way past the point of verbatim spitting out bits of code like they did at the very beginning, which is how we know it's trained on GPL code, because it would spit out GPL licenses occasionally. But we've moved way further down the road, and it's no longer. They're no longer working in that way at all. But there's definitely there's a huge IP issue with books and with art and with all sorts of other data that is harder to talk about with code, because so much of it is open source. Whether that difference in the license is important or not, which I still believe it is, but I think it's harder to talk about that with code than it is with the other ones.
Yeah, I mean, I get the point that legally it might be okay. I mean, but it's, we've already had this, we talked about this in the past quite a bit. Open source is sort of a pillar of software development, and it's not really compensated for the value it generates, right? And there's yet another facet to it where it is yet propping up another pillar of the industry and is not getting compensated. Like instead of actually turning back and helping out with the one aspect of it, there's yet another front being opened where the value is siphoned off and is powering big tech companies. I think it's just not all right. It's really not okay. And the problem is all the mechanisms to control it are much, much slower than the development. Like there's no way any legal system or any regulatory body is going to be able to act fast enough before everything has happened already, right? The development is so fast. The EU it doesn't even have the first meeting about legislation. By the time this is irrelevant. Like you say, it's irrelevant now because they've moved on to probably, like not GPL covered code, even if they have. I mean, they might not have. Who cares?
No, I think that code
is.
I think that code is still there. It just it no longer verbatim spits it back.
Yeah, they've just suppressed the signal of the means of discovering it.
I'm not sure it's even suppressing. Anyway, what we should actually do is, because we're 40 minutes into recording the podcast and we haven't recommended a single package yet. So I think we should probably put this on hold, because this is a long discussion that we will never find the end of, especially because we do have disagreements about some aspects of this. We're aligned on some of it, but we do also have disagreements. So I'm not sure we'll ever get to the end of this conversation. So let's do a reduced, brief package recommendation section so that the podcast isn't an hour long. So let's just do one package each this week.
That sounds good. Let's do that.
I will kick us off. My only package this week is a package called Package Swift LSP, which is by Vasily Katouf, and it is a language server protocol implementation for Swift package managers package.swift manifest files. So if you're not familiar with LSP, I'm not familiar with the internals of it, but I know how to use them. They are a way that code editors and other tools can interface with this LSP to find out what characters or text is available in the syntax of whatever language it is, in this case the language of a package manifest, and suggest the characters that may come next. And it's used in VS Code, it's used in the Z editor that you mentioned earlier, and I believe it's also used in Xcode for code completion as well. And the Package Swift LSP is an LSP that has been integrated now into both Z and VS Code, but unfortunately not Xcode yet, because there's no way to integrate third-party LSPs, I don't think, into Xcode. That will give you code completion on the syntax of a package manifest, including package completion. So you can add a dependency for a package, start typing the URL, and it will suggest a valid package based on the characters you've typed, and that data is actually coming from the Swift package index list of packages file. So they actually give us a little thank you in the acknowledgements of the README file. They acknowledge both Matt Massicotti's language service protocol, which was the foundation for their project, and then the Swift package index for providing a great package data for URL completion. And so if you are writing a package manifest with Z or VS Code and have the extension that they have provided, you get fantastic completion within package Swift file, better than Xcode.
I think that's really remarkable. Yeah, that these editors in a couple of cases are eclipsing Xcode because they're so extensible. Yep. Right? That's really fantastic. Yeah.
And no AI at all involved in that one.
It was actually my pick, first on my list of picks. So there we go.
Oh, I've Sherlocked you.
Yes, yeah. And that's actually via this package while trying it out. That's how I ended up using Z again. I had looked at it in the past. That's how I ended up actually in that whole LLM experiment, writing that script. Funny little sequence of events. I've been
using Z recently for the HTML and CSS work on package index, actually, because it is you definitely don't want to do HTML and CSS work in Xcode. It's not what it's designed for. Yeah. But I used to use, I still do use Visual Studio Code for that. But I've been giving Z a try, and it's very good. It's an editor written in Rust, actually, and it's extremely good.
Yeah.
So what package are you going to pick?
So in my pick, I'm going to talk about LLMs, and My second pick is a package called Probing by Kamil Streletsky. And this is a really interesting package. It essentially gives you a debugger-like execution control via checkpoints in your code. So what you can do is you can sort of, like in code, write probe points that you can advance to. It's like, imagine setting a breakpoint, except you spell it out, like stop here. So you have named scopes. And then in a test, you can actually advance to that point as if you hit continue, and then you hit the breakpoint. And then you can run asserts on the state. And I found that really interesting, that's possible, and the mechanics of it. I haven't dug super deep into it. I've tried the example that it ships with. So there's an example that fully demonstrates the capabilities. It's a little test package with an application that has probes put into it, and then tests that exploit those probes to advance to the position, and then run asserts on the state. But there's one area where I can immediately see this being super useful. And we've had this actually a couple of times where something failed, and it only failed in CI. And especially at the time, our CI ran really slow. So it took like 15 minutes. And you really just wish you were able to attach a debugger to a test and see what's going on. Because you might know it's failing in a method, or a test fails, and that test calls a method, and that method is quite large. Like, you might call other methods and you can't pinpoint where it is. So your only chance is really, if you can't reproduce it locally, your only chance would be to actually try and refactor the big method into smaller ones that you then test individually. And you can imagine how much work that would be. But with this, you can actually put probes in, that you don't need to refactor, you just put in probes, and then you can sort of, in your test, you can run to the probes, and then you can run asserts on the internal state at that point, and then you can break down the big method into smaller bits and pinpoint the problem much easier. Or actually, not just much easier, it would actually give you a chance to do it without a local reproducer or this big refactoring. So I think that's a super interesting package for that sort of thing. So if you have that situation or are generally interested in that, give that a look. It looks really, really interesting.
Well, with a slightly shorter than normal package section, we should wrap it up there, because we have now been going 48 minutes, so we should wrap it up. I think we'll have more to say on WWDC and the changes coming in Swift 6.2 and any other stuff that gets announced this week that we haven't yet watched the videos for in our next episode. But we should leave it here for today, I think.
Yeah, let's stop it there. Thanks, everyone, and see you next week. Next time, rather.
Next time, yes, in 3 weeks, something like that. All right, take care.
All right, bye-bye.
Bye-bye.